Welcome. Thank you for joining us for today's webinar, Reduce the Risk of Equipment Failure with Efficient Wire Termination Solutions, presented by Highland Electronics, Panduit, and TechBreeze Media. Highland Electronics is a global distributor of interconnect, electromechanical, and sensor products and is authorized to sell Panduit's full product portfolio. I'm Bruce Bennett, editor at TechBreeze Media, and I'll be your moderator today. This webinar will last approximately 60 minutes, and there will be a question and answer period at the end of the presentation. If you have a question, you may submit it at any time during the presentation by using the Ask a Question box on your screen. Our speakers will answer as many questions as possible at the conclusion of the presentation. Those questions not addressed during the live event will be answered offline. You may also download a PDF of the presentation slides under the Event Resources tab on the left of your screen. To view the presentation properly, please disable any pop-up blockers you may have on your browser. At this time, I'd like to introduce today's speakers. Vince Barone, Panduit's Product Strategy and Enablement Manager, leads several teams that focus on developing automated tooling solutions and wiring components. He holds various patents and has authored articles on increasing productivity with quick termination tools and other solutions. Currently, Mr. Barone is responsible for the continued development and growth of the Panduit Stronghold product offering and continues to drive key partner relationships within the industry. Brendan Haas is the product manager of terminals, RealSmart, and wiring duct products at Panduit with an OEM focus. Brendan also brings an industrial construction background to the role by previously managing the company's grounding and bonding solutions. He has contributed to Panduit's technical literature by writing white papers and reviewing articles on subjects like industry standards or project profitability improvements. Now that you're familiar with our speakers' qualifications, let's begin today's presentation.
So good afternoon, and thank you everyone for joining. My name is Vince Barone. Thank you for introducing me. I greatly appreciate it. Today we're going to be covering quite a few different products and benefits of using different products and termination correctly. A little quick brief on Panduit. We do support the world's most challenging environments. Panduit is a billion-dollar global manufacturer of physical infrastructure equipment that supports power, communication, computing, controls, and security systems. As one of the leaders in the world of innovation, Panduit has over 1,800 global patents and more than 900 U.S. patents alone, and internationally provides solutions with engineering support to many special and demanding installation designs, from maintenance to infrastructure, to ensure the performance and safety, and also to be cost efficient. So today I'm going to be speaking myself. Again, you guys had my introduction along with Brendan Haas. We're going to be covering a couple different things here. So the top level thing is reducing risk of failure. Ensure proper installation and termination of wires, efficient processes, and ensure quality performance and reliability. So how do I reduce risk of failure when I'm looking at putting wiring into, whether it's a control panel, a motor control, an aerospace, a Boeing 747? There's quite a bit to be looked at when doing this and designing with the right products in mind, the right wiring. First, you want to design with the right products that meet industry standards, whether that's UL, CSA, DFARS, or any other standard that you're working with for a particular application. You want to make sure the product you're picking works in the application environment of the end product, not just where it's installed within a manufacturing facility, but once it's out in the field, what is the environment going to be used in? And it will provide reliability and performance over the life of the product. Depending on what you're using it for, you might be doing something temporary. That may not need a higher end product. Whereas you're doing an automotive or a rail infrastructure, you're going to want to make sure you have the right high-quality product that meets the application need. Once you've selected the right products, the proper crimping and installation of the connector is just as important as selecting the right product. You need to have the right tools, which are easy to use, providing a consistent result, not just one or two times, but you want to be consistent over the time of installation. Products should be tested and certified with connectors and tool combination. Most customers do not realize that the end tested product to meet a certification, such as UL as an example, is not just the terminal on the wire. It's the terminal, the tool itself, and the wire used that gets you the UL certification. So it's important to have the combination of all those pieces together. And then it needs to be an efficient process with lowest installed cost. Again, labor costs continue to go up globally, and you want to be as efficient as possible with the lowest installed cost. And lastly, we want to inspect to ensure the performance and reliability. Know what to look for. When you're looking at a termination, it's very important to visually inspect and know the key areas that could potentially cause failure in the future. Take the time for quality. I can't express enough that a bad crimp, if detected within the first few minutes, is pennies. You simply cut the termination off and re-crimp. If it's within hours, it could be thousands of dollars. Within a day, it could be hundreds of thousands of dollars. And you can tell that it just keeps escalating the longer you take to identify that you have a bad process. It reduces customer complaints and service work when you do the above. It's all about reducing the rework and making sure that your customers receive the best quality product at the end of the day. So for today, we're going to talk about a couple different pieces of selecting the best options with some case studies. We'll talk about application, proper wiring, selecting whether it's a terminal or a ferrule. We'll talk about some of the industry standards that apply. Crimping best practices, which include selecting the proper tool, performing a quality crimp, but not just being able to grab a tool and crimp something on as hard as you can, but to be actually do a good quality crimp consistently. Increased productivity comes along with these tools as well. And then, of course, inspection, as we just talked about, and what that payback looks like when done properly. So I'm going to hit this real quick just one more time here. Did you know that the leading reason of warranty claims on electrical assemblies is due to poor electrical connections? Whether it's the termination or connecting it to the end device, it's the leading cause of warranty claims. And again, those costs, if detected early on, are pennies versus thousands to hundreds of thousands and potential recalls in the future. So what are terminals and ferrules? Terminals or ferrules are the hardware that goes on the end of the wire. You take a wire, you strip the end, and you put the terminal on the end of the ferrule. And it's what actually connects to the actual device, whether it's a terminal block, a screw down connection point, or a fast-on connector. Those are what terminals and ferrules are. They actually make that connection point between the wire and that of the physical end device. So we look at terminals, a little bit about the history here. We all started off with rings. The great thing about rings is they're very secure. It's a great crimp. When done properly, it's a good crimp. You loosen the screw, take it out, you put the screw back through the terminal and thread it down onto the terminal block. The challenge with those is, while they're great for certain applications, they do take time to install. And as the history went on, people wanted something faster. So we came out with forks. So now all you do is loosen the screw and slip the fork underneath and then tighten it down. Again, there's a couple different styles we'll talk about for your application, which might be best. But then people wanted to go even faster. So now you've got a lot of switches and devices that have the male tab on them, and disconnects, which you see in the bottom right there, simply slip on the end device of the male tab and make it a very quick installation. So that's some of the things that have happened over history. So what are some of the industry best practices for product applications? Design with the right product. Know the voltage and current rating to determine the right wire size. You'd be very surprised how many times people go in and just simply grab the wire that's available and think it's electrical wire. I'm going to hook it up and it's going to run a current through it. It's going to work fine. Not really understanding the voltage and the current requirements can lead to fusing. The wire is just simply not large enough in diameter to actually support the voltage or current going through there, and you actually cause breaks in the wire and fusing and failure. So selecting the right wire up front is the most important. The dynamics around that are determining appropriate terminal and or ferrule depending on what you're connecting to. With control panels getting smaller and smaller in the industry, we're seeing a lot of manufacturers take what used to be traditional terminal blocks. You guys are very familiar with them, with the screws in them. They're wide, spaced apart. They're going to have a plastic barrier in between. Those are great for rings and forks that are insulated. But as they get smaller and smaller, the rings and forks don't fit as easily. And ferrules have been introduced in the market. You're going to about 30% less space consumption within a control panel for the same amount of connection points. So again, knowing the end device, what you're connecting to, is important to know which terminal, whether it's a ring, a fork, a disconnect, a splice, what you're going into, it's important. And then lastly is the environmental conditions. Determining appropriate terminal materials. So when we look at terminals, there's the non-insulated, which is basically a stamped copper plate, and it's formed into a ring, a fork, a disconnect, or a ferrule. They're then tin plated. That's your traditional stuff you're going to see out in the marketplace everywhere. The tin plating is there to prevent against corrosion. Now, as you move up, you start going to insulated connectors. We talked about those large terminal blocks and that plastic barrier in between them. If there's enough space in between the two connection points, you wouldn't need an insulating barrier. But again, as things are getting smaller and smaller and tighter, the need for insulation to prevent a short from one terminal to the next, introduce insulation sleeves, whether they're vinyl or nylon, or kynar, which is a higher temperature nuclear rated material. Again, you're going into a Class 1E plant. You're going to want to make sure the material is appropriate for that environment. And then there's also things such as nickel plating, which gets into very high temperature applications, 500 degrees Fahrenheit, motor engine controls, compartments where it's extreme heat, and the product needs to have a higher resistance to temperature. There's a variety of different materials out there to be used. The best thing is go look at the application, pull up a terminal selection guide, which will show you the materials and the good, better, best. It'll go through whether it's applicable for certain temperatures, certain chemical environments, whether it's a radiation environment, or just simple day-to-day use would be like a nylon 6.6 tin-plated terminal. Industry standards are very important. They're required in many, many applications. Some require listing versus recognition. Recognition means that the product's been tested to a certain level. It can be used within a control panel. It's a recognized component, but you still may have to do testing of the end assembled device. Listed components can stand on their own. The terminal or the ferrule has been tested. It's been crimped on an end of wire. It's been run through voltage testing, dielectrics, heat aging. It's done pull force to ensure the crimp is done properly and it's going to hold under a certain load. And those are components that can stand their own. Those are listed. There's also things such as American Railway, DFARS, which is a military shipgoing vessel regulatory compliance, American Bureau of Shipping, IEEE, and many others. When we start looking at high vibration, we're going to talk a little bit more now about some applications, get a little bit more specific here. A high vibration application could be a manufacturing facility, manufacturing plant with a lot of moving components, conveyors, stampings, and other things going on. Transportation, we talk about rail industry, aerospace, heavy truck and bus, and even white goods. You're talking about washing machines and dryers where there's a constant amount of motion and vibration. The challenges with these is you end up a lot of times with intermittent connections. Connections can become loose. When a connection becomes loose, it causes increased temperature. When there's increased temperature, we increase the acceleration of corrosion. Corrosion then causes more high temperature and then more corrosion. And you can see it just becomes a domino effect until there's an actual failure. Some of the solutions, and these are just some of them we down here, would be high vibration disconnects. So again, we talked about those male tabs earlier where you simply slip the disconnect onto. A day-to-day disconnect in a high vibration application may not be sufficient. There are special disconnects which are designed for high vibration that have a tighter curl height on them. And it's a little bit more force to put them on, but the chances of them coming off under high vibration is greatly reduced. The alternative solution would be go to a ring and a stud. Again, you're going to take that screw out of the connection device, put that screw through the ring, and then you're going to torque that screw down to the proper torque tension to ensure that it doesn't come off. It's a slower installation, but it is a higher guarantee than other forms of termination. Double crimping is also an option. Many of the new components out there today, whether they're a ring or fork or even a disconnect, have a metal insulation grip sleeve. So if you've ever done a termination, you strip the wire and you crimp that barrel onto the wire really hard. That's a single crimp. The double crimp has an extra metal sleeve that actually crimps onto the insulation of the wire. It actually acts as a strain relief as well. It's just an added protection so that things are moving around at a high vibration, that the load is not necessarily on the crimp of the wire, but it's also using that insulation on the wire as a load, preventing any movement left or right, up or down, rotationally, and preventing a loose connection. Earlier I mentioned those high temperature applications. Again, we're talking about transportation, aerospace, exhaust and engines, control panels, hot environments, plants, could even be solar out in the desert type of applications. Challenges again, we talked about that corrosion due to heat buildup and the failure and decreased efficiencies. Some of the solutions on the lower end is going to be your nylon. It's just going to be an added layer of protection. But as you go up and you start talking about higher temperatures, you're talking Kynar. It's a specialized material that is designed to withstand the high temperatures of these environmental applications, and it's also even nuclear rated. You then also can go to the next level of saying a non-insulated, nickel plated. Again, it's used in all different types of environments. The great part about that is that it is the plating on there is designed for high temperatures. We start talking about the next level of application is high maintenance applications like control panels, MCC, motor control centers, even white goods where there's a lot of repair at times. Things are coming in, switches need to be replaced rather quickly and easily. It's a convenient. The challenge is you want convenience. You want it to be reliable. That's always a challenge when you're taking things and removing connection points and putting them back on or changing things out. is the reliability of the connection, and then speed. Anything that's coming through a maintenance facility and you need to change something out, time is money. So being able to install these things quickly and easily is extremely important. Some of the solutions behind those would be ferrules crimped on the end of wires where there's a lot of high flex cabling being used. Know that flex cable on its own is not allowed for use within a control panel without being crimped, a ferrule being crimped on the end of the wire. UL does not allow it. The reason is because that flex cable, when you put it in the end device, if you screw down those high stranded cables, which used to be typically a stranded cable would be 7 to 14 wires. These high flex cables could be anywhere from 32 to a couple hundred strands, depending on the size of the bundle or the size of the wire. And when you torque down with a screw, those wires either they break, fracture, or they flare out. You also get some false torque readings when you get wires bound up in the screws. And if you torque them down and it looks great one day, you go back the next day and you move the wire and it falls out. It's required that you put the ferrule on the end to create a solid code-like cable for more reliability. And that makes it much easier as we start talking about these control panels where they're moving away from traditional screw-down terminations to that picture you see there on the left where there's a screw in there, but they're so tight up against one another, they're very small termination points, you actually slip the ferrule in up underneath and torque down with those as well. There's also disconnects and forks that can be used as well in some of these applications. Disconnects, you see a lot of those being used in the white goods industry, where there's a lot of switches that already have that male tab installed on them. If you have to replace a switch, it's very simple just to remove the female disconnect and put a new switch in and then reconnect without having to re-terminate. It makes it very fast and easy to use. Screw down applications like rings and forks, it's a final installation. It's one of those ones you're not going to be taking off on and off rather quickly. There are static applications like forks and terminal blocks. Challenge is always secureness and speed of installation. The two first upfront choices are going to be your rings and your forks. The ring, you're going to have to remove that screw fully. The fork, you have to loosen it and slip it in underneath. So it makes it a little faster, but again, you're still having to use a screwdriver to remove that screw slightly and slip it underneath. The one picture down at the bottom right here is a little bit of a challenge picture here. If you look at the top picture there, you're going to see how the wires are spaced, and there's that plastic barrier between the termination points. That is actually a design through UL that says a certain amount of distance traveled must be between one connection point and the next to prevent a short. That's why those plastic barriers are there. The bottom right picture was an actual application that someone designed an effort to create fusing so something would be overpowered. What they didn't realize, though, is that when they designed this one, that the fuse itself is right next to the left side termination point, and that fuse is going off all the time. They were creating a direct line of short because they had actually violated the spacing requirements needed to prevent a short. So again, these are things you need to look for when you're out there. While the concept, the idea was great by the end user to do this, they actually caused a failure in the industry. So the best of both worlds, as we talked about the previous slide of being able to use a ring or fork in that final installation with a screw, is what is known as a locking fork. It is an open tongue, similar to the fork. It has funnel entries, makes it easy. It's got this teardrop shape there. If you look at that bottom right picture there, you see that the image on the right, there's that teardrop shape there. What that does is when you loosen the screw, the fork actually slips underneath the head of the screw and over the stud, and actually is an audible click. It actually snaps onto the stud. It goes on like a fork, but stays on like a ring. Again, for that high vibration application, should that screw loosen up, yes, you're getting the speed of the installation of the fork, but you're getting that secureness like the ring that if it did loosen, it's not going to fall off. So again, it's the best of both worlds at that point. When we start talking about printed circuit boards, we start looking at, this is where you're seeing a lot of those disconnects show up. You'll see them in battery backup systems, controls, lighting fixtures, digital devices. One of the biggest challenges we've seen in the industry is spacing of connector points, the voltage draw and sizing of the disconnect, because there are different sizes and thicknesses of disconnects, and the temperature heat rise that gets created by not properly spacing these or having the right size or number of termination points, where you actually will split the voltage into multiple connection points to reduce the amount of heat. The solution there is always going to go back to design. It's the design of the board layout, knowing that there needs to be a 1/4 inch spacing between a positive and negative wire for voltage coming in. A lot of people will stack these things right next to each other and not realizing they need that spacing. And then they'll see a few months later or even a month later that the disconnect has turned charred and brown, and they're saying, hey, there's a problem with the disconnect. And what you come to find out is that the disconnect's not designed for that type of application where it's such a tight spacing that the voltage going through is actually overpowering, overheating the board, and then causing the disconnect to discolor. So sizing the wire correctly, number one, the right size of the disconnect, and the proper spacing is the most important piece when designing this type of application. Some other areas where I've seen this happen again is where proper spacing is important is motor control capacitors. Those bottom pictures there, you'll see that there's a positive and negative, but there's multiple tab connection points. Again, that goes back to what I mentioned in the previous slide of splitting the voltage to different connection points to reduce the amount of heat and current being put through any one connection point. Those capacitors are actually designed with the intent to have multiple connection points. It's not so you can always just go ahead and daisy chain these things together. It's to actually split the voltage and reduce the amount of heat and current through any one connection point. All right, as we keep going forward here, terminal block applications. You're going to see these things in all different types of areas, whether it's in the aerospace, mining, white goods, wind, solar, anywhere control panels are used. The terminal blocks are becoming smaller and smaller in size. A lot of them are gone away from the old traditional screw down type where you put the little screwdriver in and you loosen the screw, slip a fork or ring or a ferrule up underneath and screw it back down to what is known as cage clamp designs. It's a spring-loaded locking mechanism where you take a wire, you crimp a ferrule on it appropriately sized for the wire and for the end device. And what you then do is push that hardened code-like cable with the ferrule into the end connector inside of the terminal block. Now, depending on the terminal block and the manufacturer of the terminal block, depends on the shape of the crimp. So it's not just going out and grabbing a ferrule, putting it on a wire, grabbing a tool and crimping it. It's knowing which shape is best for the terminal block being used. Certain manufacturers have what is known as a square cage clamp. It comes in from all three sides. The best termination for theirs would be a square crimp because they're getting surface contact on all four sides. Others have a top and bottom a spring-loaded design, and a trapezoid would be better for theirs because you're getting more surface area on the bottom contact, reducing the amount of heat rise and draw because you have more surface contact. So again, it's not just about putting the ferrule on the end of the wire and making sure it's designed for flexible cable. It's also knowing the endpoint device and what shape is best for it. The other key note there is to know is that ferrules are UL listed. Okay, they're not just UL 508A approved anymore. Up until 2014, there was no UL listing for ferrules. And UL did allow for the use of ferrules in a control panel if it was done in a certain way with certain tools up to a certain size and only in certain instances under UL 508A approval. Many folks were very hesitant because the standard did not give you any test criteria. All it told you was that it's approved for use. It didn't tell you the load, the proper termination. It didn't tell you about how much pull-out force was required or how to even test it. So best for termination wires and mechanical connectors is definitely understand the shape and the stripped end and high-stranded applications, knowing that ferrules are designed for use with flex cable. They are similar to what you call your shoelace. If you've ever taken that little inglet off the end of your shoelace and tried to feed it through the holes in your shoelaces, it's very difficult. You can't do it. It kind of contains all those wires. It makes it easier to put in the end device. Sorry, I keep on losing connection there, guys. I apologize. But back again. So this is just one of the applications we saw out there with ferrules, is that when you take those high-stranded wires and flex, the wires want to flare out very heavily. And what happens then is you have to size up the end device connector in order to get those wires to fit in. With the use of the ferrule, you actually can contain all those wires and not have to size up on the end device, making it more cost effective. You think about a 600 kc mil type of application where you have to size up one level up, you're going to be spending more money on the connector device. With ferrules, you eliminate that need to size up. The solution is the large wire ferrules, the large wire dies, and the proper tooling.
All right, so it seems like Vince is having a little bit of a connection issues, so considering we're near the handoff anyways, I'm going to go ahead and take over. Just to remind you all, my name is Brendan Haas, and I'm the product manager of Terminals, RealSmart, and Wiring Duct products at Panduit. And so here, as Vince was saying, you know, there's a different need for every application, and we're just highlighting here on this slide that there are other different types of connections, such as splices and wire joints if you're connecting wire to wire, and then pins and blades for maybe more of those older style connections. We've seen those kind of go to the wayside nowadays, but those could still be relevant for your application. And then one more time, rounding off some of the insulation materials and barrel types, just be aware that there are different ways to protect the connection. It depends on how much of an investment you want to put into the material versus what the demand of the environment is. So you can see here the non-insulated version will not have much protection unless it's nickel plated. Then it is good for corrosive resistance there and high temperatures. You move towards the bottom end with vinyl. It's flame resistant. It's more so your typical product. Moving up to nylon, you become halogen free. It's more malleable plastic. And then all the way up to Kynar, which is very high temperature rated and chemical resistant, as Vince has been mentioning before, nuclear rated and things like that, depending on the manufacturer. And then lastly, heat shrink, if you'd like an extra moisture resistant barrier to fully encapsulate the connection. So we're going to move on now to talk about industry best practices for proper crimping. And at Panduit, we pride ourselves in quality. We promote it and praise it out in the industry as well. And quality is key to note. It's not solely based around the products. A manufacturer can put out the best product they can, but if there's no solid process in place to have it applied or used, the quality of the product itself means nothing. And so you can see here there's a good quote at the bottom of this screen. Quality is not made, it is a byproduct of having a process that works well and can be repeated reliably. And so with crimping consistency, you can improve the performance of your end product and have the performance better be predicted. So what can happen if a connection is not consistent or if it's done wrong? There's some obvious errors that can occur, such as intermittent connections, bad connections, but electrical shorts can also come out of this due to possibly bent back strands, or if a connection comes completely loose. And this, again, as we were sort of harping on, can lead to potential downtime or even product recalls. So when you're going into a process, determining the best steps forward for actually applying a termination, you'd want to first make sure that you're selecting the proper tool. This could be due to convenience, investment costs, what have you, but typically in the industry, everything is applied by a die-type controlled cycle mechanism of some sort, whether that's in a manual tool, a battery-powered operational tool, or a hydraulic press-type tool. And so after you select the proper tool based on volume, convenience, preference, you can then worry about focusing on the quality of the crimp, as well as then how that can increase your productivity later on by the appropriate inspection and not having to do things over. So we'll go ahead and talk about each of the individual types of tools here, starting out with the lowest volume, most economical, and most common, maybe, out in the field, and that are plier-type tools. And you'll see these come in a variety of shapes and sizes, most of which trying to pack in the most amount of functions into the tool as possible. The idea there is that it's low weight and the electrician or repairman or installer only has one or two items in their pouch on their belt. And these are easily replaced and again economical choices, but do not have any feature to sort of control the quality of the connection, as opposed to these next few guys here, which are control cycle tools. And these will usually have some sort of die or precise way to crimp a connection. The first one seen there is for ferrules, the next one possibly for splices, ring terminals, forks, and alike. These are normally more expensive than your plier type tools and only have a single function, but that function is really honed in. And the whole process is what we call a control cycle, in which case the tool does not release or does not allow you to complete the connection until it's properly done all the way. Because you may have, with a plier type tool, a very strong, fresh, young, caffeinated installer early in the morning, making great connections, maybe even too hard of a connection and break some strands when applying a crimp. Or you could have maybe an older installer later on in the day who is struggling to sort of make those last few connections with the plier type tool, where if those two individuals were using a control cycle tool, you could make sure that the outcome would be exactly the same. And so moving on then, the next step upward would be some sort of battery operated mechanism for that controlled cycle. And so in the industry, there's been recent development towards these micro crimping tools, which feature the control cycle mechanism, but also have a very nice ergonomic tool design and a very wide range of crimping capability to reduce the amount of exchange of tools again, but also reduce the amount of, repetitive motion injuries that could occur, and are really a convenient option all the way across the board. A little bit more expensive typically than just the manual control cycle tools, but again, it depends on the application and on what the return on investment for the entire project would be. These tools, the Panduit specific brand, is now offered with a fast, intelligent notification software, quoted as FINS, that can also be a great benefit to a project, which allows you to track crimps, appropriately log different connections that are made, and even requisition out a tool to a specific individual to know where it is. And so just all around the battery operated tools seem to be a good option for multiple connections per month, upwards of maybe 50 to 100,000 a year, and are really convenient for the health of the operators as well. So then we'll move on to the automated RealSmart crimp solutions. These are usually seen out in the fields as your amp presses, your TE, typical tools, which involve a very large source of hydraulic power into what we call an applicator. And that applicator houses a different type of crimp die and cutting mechanism to be able to efficiently and consistently make the same crimp onto a wire and eject the crimped solution while maintaining sort of a reel-fed type solution to the products to be able to continually feed more connections. And this is going to, again, be used for those higher volume type applications. So after you've selected your correct tool, you know that the outcome of those tools is going to be efficient and correct. You'd want to go ahead and go back in and inspect all of the connections that have been made. And so we would claim that inspection is the most critical step in the crimping process. On screen here, you can see 3 of the connections that are poor connections that are most common out in the field. One would be bent back strands, which is the leftmost picture. The central picture is of an incorrect crimping tool to be used to crimp the connection. And then on the right there in red is a improperly oriented crimp. It is not perpendicular to the blade. It is actually parallel to it. And so with these different types of misconnections, you'll increase the chance for electrical shorts out in the field. And so there's a key thing to note about the insulation connection and crimp that Vince was talking about earlier. This adds a layer of increased reliability to the connection by allowing the wires to maintain their position and not be frayed or wiggled out of position or severed even. And so you can see here in this picture on the top there's no sort of crimp connection of the insulation over those blue wires, and that copper wire that you can see exposed there is free to wiggle about, potentially cause some bent back strands, touch one another, cause some shortage there and whatnot, whereas in the bottom, properly spaced, properly crimped onto the insulation will be a much more reliable connection. So I have a picture here I'm going to leave up for a few moments, and I'll let you all sort of take it in. And the idea here is on the next slide that I'll go ahead and cover sort of the areas in which there are some errors taking place here. So I'll give you 30 seconds or so to just sort of look this one over. All right, so keeping in mind everything we've talked about so far, we're going to start over on the left and see that there's no insulation crimp done on this furthest leftmost connection, again causing the wire to possibly move about, sever itself, or become a little bit intermittent. On the bottom, there's a fork stud that is too large, might be hard to tell, but you always want to make sure that you properly size the connection per the stud holes on the drawings that the manufacturers provide. Each of these installations as well have the indentation mark, not typical for this type of connection, so you could tell that it was possibly crimped with the wrong tool. That's going to go ahead and increase the resistance on each of those strands, again, to Vince's point, causing some different corrosion problems, heat problems, and further failure that's possible. Over here on the right, you can see that the strip length was maybe a little too long, and there's some exposed copper coming out of the top of that. Again, there was not another insulation crimp done there, so that is very susceptible to being pulled out or coming apart. And then lastly, there is a fork terminal being used for a grounding connection, and obviously that may not have been apparent on the screen, but a fork terminal for grounding is not advised unless it is possibly a locking fork, but most standards would call out a ring-style termination for a grounding connection. So again, we'll bring everything back to our original points. Everything noted so far has been to try and help you design, implement, actually create and install a solution that's reliable with high quality and reduces the amount of poor electrical connections that are made. Because again, the cost to repair a poor electrical connection is very little at first, even more as time progresses. And if total failure occurs and there is a recall or someone is injured or hurt due to the poor connection, it could be thousands, tens of thousands, if not millions of dollars later. And so I know throughout this last section here, it's difficult to talk about proper techniques for crimping, as well as all of the minute details that you'd have to go into to know all of the connections, perfectly. So without further ado, we'll give you a little taste of our additional crimp training available through Panduit. That's known as Success Depends on the Crimp.
The crimp within the scope of any project is a small piece of work. A proper crimp is the key element in an overall wire termination assembly that is unfortunately all too often overlooked. It's a small thing, but success truly depends on the crimp.
All right, so I'd like to thank you guys so far for the presentation. We're going to go ahead and pass it back to the operator here for a brief question and answer session. So if you haven't already, I'd advise making sure that your questions are in, and me and Vince will answer them momentarily.
That is correct. I'd like to remind our audience that if you have a question, you may submit it simply by using the Ask a Question box on your screen. Okay, first question here. Let's go to Vince. Are solid wires ever crimped to a connector?
So good question. Are solid wires ever crimped to a connection? The answer would be yes. I know in certain applications that may not be true. You think about typical home wiring, an electrical outlet or a switch. You'll strip that wire, you'll put the hook into it, and you'll wrap around the screw, and you'll torque down on it. In that situation, you wouldn't need it. But let's say you're taking a solid wire and hooking it up to a switch that has a male tab on it already. there's nothing to connect to. You would actually have to terminate a disconnect onto the end of the solid wire and then attach the disconnect to the end device, which is a switch with the male tab. So depending on what you're connecting to, there are instances where you will have to put a terminal, whether it's a ring or a fork or disconnect or some other type of terminal, on the end of the solid wire to connect it to the end device application. So the answer is yes.
Thank you.
Good question.
Next question. What is the most common cause of electrical failures?
So let me repeat that. What is the most common cause of electrical failures out there? The most common cause of electrical failures in any application has always been an improper termination or connection to an end device. Again, when they're hooked up, they may look sufficient because many folks don't necessarily know what to look for. As Brendan showed you guys in those slides or that picture you had you take a second and look at, my question normally would be when doing this type of training in front of a group and doing the actual hands-on portion of training and selecting the tools and the crimps would be to ask the question when looking at that picture, take a moment, look at it, and identify as many things as you can that might be wrong. I would go into my presentation a little bit further and come back to that slide. And I would show and highlight, as Brendan did, those areas that were not properly done correct. I'd ask the audience, how many of you got at least one of those right? And a lot of hands would go up. I'd then ask, how many of you got more? You got two of them. A lot of hands would come down, but you still get a good group of people who might get two things. You get to three, and the hands start to drop significantly. And you'll get a few folks in the class, 20, there's maybe 3 people. Then you ask the question, how many got 4 or 5? And you'll get not a single person in the room has ever captured all 5. Again, it's knowing what to look for. It's not just about going ahead and taking a terminal and putting it on the end of the wire and crimping it really hard and saying, look, this is a great crimp. I crimped the living heck out of this thing. It's never coming off the wire. Mm-hmm. You're right. You did, but you pierced the insulation. That insulation is intended to prevent a short to the next wire next to it. You just pierced the wire and created a direct line of short to the wire next to it. Again, not understanding that is very common, and that's why electrical terminations are the most common electrical failure in the industry.
Thank you. Now let's go to Brendan for a question. Can you give us an update on the quality issues with the Real Smart terminals?
Sure. So it's not necessarily a quality issue per se. Panduit Manufacturing has advised a stop to production briefly on only a few select part numbers. We've actually sent out a letter to all available salesmen and customer service. So if you'd like to take a look at that letter about our official statement, you can feel free to reach out, and we'd be more than happy to share that with you.
Thank you. Here's another one, Brendan. What are the UL 486 or UL 310 performance requirements for terminations?
Sure. So there's a variety of different tests that the product has to go through, dependent on wire style, the style of the connection, whether it's a terminal, a splice, or a disconnect, and so on. So I'll just address it off the top here. 486A is for terminals. 486C is for splices. UL 310 is for blades, as well as disconnects. And the amperage ratings vary between 3 and 80 or so, depending on the wire size. So that's from number 26 gauge wire to number 10 gauge wire. And pull-out tensile strength, again, could vary from around 3 pounds to 80 pounds.
Thank you. All right. The next question that just came in. Are Panduit crimpers in compliance with a certain standard?
So
Or I
while
can
I'm
hop.
rattling, okay, go forward, Vince.
Yeah, so the tool itself is not the only thing that gets listed. Now, Panduit tools are ISO certified for safety. They do meet, especially with our battery operated tools, they are the only tools in the world that are ISO compliant for safety compliance. However, the tool itself is not what gives you the final UL listing or CSA listing or IEEE listing. It's the tool in combination with the terminal and the wire being crimped that is actually tested and submitted to UL to be compliant. So taking somebody else's tool with Panduit dies in this example may give you the same crimp, but it may not be a UL listed crimp because it's never been tested or submitted for compliance. Panduit has done a lot of testing with various different vendors, dies and tools to ensure that when you crimp our terminals or our power connectors, that when used with those dies, that you do get a UL crimp. So we've actually taken our product, tested it with a number of different variations of wire, whether it's K, L, M, DLO, high flex cable, etc., and tested it with all those different styles of dies and offerings by different manufacturers and tooling to ensure that you do get a UL crimp. Now, we can't do that for every tool in the world. So we do have charts that show which tools are compliant with our product and will give you a UL crimp or an IEEE crimp. But again, the tool on its own cannot stand as a UL listed component. Now, there are UL tests that are required for a tool with regards to like battery power and such forth that you need to meet certain industry standards and safety such as OSHA. But to be actually a termination part and saying the tool itself is what's giving you the UL listing, no, there isn't. It's the combination of the actual product with the tool and the wire. Hopefully that explains it. I know it's a lot of words, but there's a lot to that.
Thank you, Vince. I'm afraid that's all the time we have today. I'd like to thank Mr. Baroni and Mr. Haas for giving us such an enlightening presentation, and I'd like to thank today's attendees for participating. That concludes today's webinar, sponsored by Highland Electronics, Panduit, and TechBriefs Media.